Welcome. We'll be taking a look here at a question where data has been provided to us. So it says Chester claims his churros have a mean of 300 calories. A researcher challenges this claim and heads out to gather evidence. So the researcher selects a random sample of 10 Chester's churros. The number of calories in each churro follows. We'll assume the variable is normally distributed with a population standard deviation of 30 calories. It'll be important here to note that population standard deviation has been provided. We will be finding a 95% confidence interval estimate for the true population mean calories in all of his churros. All right, so first step if you have data is to get it into a calculator list. So I've done that already. Stat edit and enter the data. So if you wanted to pause the video and enter your data, that is step one. All right, so in this problem, we are estimating the parameter mu, the unknown population mean, and population standard deviation sigma has been given as 30 calories. So we say here that sigma is known. So when we're estimating a population mean and sigma is known, this is the scenario that allows us to use a Z-interval to create our confidence interval. But before we do that, I did want to write down the best point estimate for mu. So your best point estimate for a parameter is its corresponding statistic. So sample mean is our best point estimate for mu, population mean. And I'm just going to run one var stats just to find that value. So stat calculate one var stats, and my data is in L1, so I can just hit enter, and then I'll see at the top that the average calories for these 10 churros was 325. So that's our point estimate. And then we'll use our Z-interval to find our confidence interval estimate. So stat tests Z-interval. And then if we have data, you want to make sure for your input, you select data. So make sure when you move down that data is highlighted. So data's been selected. Enter your sigma. Your list will be L1. Frequency is always going to be 1. That just means there's one of each number. And confidence level, 95%, so 0.95 there. And calculate. And we're going to round to a whole number here. So the lower limit would be 306. And then we're writing it in this form. So lower limit and then less than. The parameter we're estimating is mu, population mean. And then less than my upper limit there, 344. I'm going to draw a sketch of that. So there's my lower limit, just approximate is fine, 306. My upper limit, 344. And then my point estimate, that single value is at 325. So my sentence here, I can say based on a sample of 10 churros, we estimate with 95% confidence that the true mean, so true and population, we use interchangeably here, the true mean or the true population mean calories in all of his churros. So based on these 10, we believe with 95% confidence that for all his churros, the mean calories is actually somewhere between 306 and 344 calories. Now I actually want to write this one in the second form. So starting the same way, based on a sample of 10 churros, we estimate with 95% confidence the true mean calories So an equivalent way to express the interval would be to say that we think the mean is that point estimate, 325. So that's our X bar. And then accurate to within. So when we see within, we know that that's referring to our margin of error. So on my picture here, I'm just going to find the margin of error this way. So the margin of error will be that distance from our point estimate to our lower or upper limit. So let me find my margin of error just looking at this distance. So 344 minus 325, that's a distance of 19. So that would be 19 calories. You could check the other side as well. That distance there will also be 19. So I think that the true mean is 325. Accurate to within, I'm accurate to within 19 calories. So this would be the plus or minus part. So 325 plus or minus 19 calories. All right, last part here. Does our confidence interval constructed contradict Chester's claim that his churros average 300 calories? All right, so the claim made by Chester is that 300 is the true mean. So that is Chester's claim. So his claim was that mu was 300. So it appears we do have a contradiction here. We think it's between, the mean is between 306 and 344. So he is giving us a value outside of our interval, causing a contradiction. So the confidence interval does contradict Chester's claim because 300 falls outside of our 95% confidence interval. All right, so we're going to follow through with one more example here regarding the churros. So when we conduct a study, we do have to determine our sample size. So let's say that we would like to conduct our own study here on churros. We would need to figure out how many churros we need to sample. And the number of churros that would need to be sampled are going to be based on two things: how confident we'd like to be in the results of our study, our interval, and we also want to take into consideration how accurate we'd like to be. In other words, how big of a margin of error are we willing to accept? So let's say that we do want to construct a 95% confidence interval, and we want our estimate to be within 8 calories of the population mean. So above the margin of error was 19 calories, we're only willing to accept an accuracy of 8 calories. So we want a smaller, so more accurate, sorry. We'd like to be more accurate because we'd like our margin of error to be smaller. All right, so if we'd like our margin of error to be smaller, generally speaking, it means we're going to need to collect more data than those 10 churros above. So we want the same confidence as above, but we want to be more accurate by having a smaller margin of error. All right, so let me just start with writing some of the given information here. So our confidence level, 95%. And we're going to need the critical value, Z alpha over 2, corresponding to a 95% confidence interval. So we're headed towards this formula. So for 95% confidence, that Z-score is 1.96. If you wanted to review the shortcut to find the 1.96, I'll just review that quickly. So if I go back to my Z interval and move myself back to statistics, stat, and then if you enter 1 and then 0, 1, and put in the confidence level, That's the shortcut there to find Z alpha over 2. So the positive number is your Z alpha over 2. And then my margin of error is 8. So E8. We're still assuming our population standard deviation is 30. All right, and then I'm ready to substitute. So here's what the formula looks like. We're trying to find N, our sample size. So it will be our Z alpha over 2 times our standard deviation, and that will be divided by the margin of error. And then that whole quantity gets squared. So I'm going to write it horizontally here to show you how I enter it on the calculator. So I'm going to open a parenthesis. I'll put in my Z alpha over 2 value. I'll multiply that by sigma, which is 30. Divide that by margin of error, which is 8. Close parentheses, and then square that entire quantity. All right, so on my calculator, exactly as I wrote it there, 1.96 times 30, divide by 8, close parenthesis, and then square. I'm going to write down that entire answer, 54.0225. All right, but this is sample size. So this is how many churros I need to sample. So if I was going to the store and buying churros, you can't buy 54.0225 churros. That doesn't make sense. So you're not going to buy a piece of a churro. So this needs to be a whole number. And the way the formula works is this value is minimum. So at the very least, this is the minimum sample size. So you can't go lower than that. All right, so if you can't go lower than that, then that means if we want a whole number, you're always going to have to go up to the next whole number. So rather than thinking of it as rounding, because if you just rounded it, you would say 54. We're not really rounding here. We're saying this answer, this is the smallest number possible. So 54 would be lower. We need to go higher. So 54, we would have to go up to the next whole number. And so we would need 55 churros in our study. So that's the minimum sample size. We always go up to the next whole number. It must be a whole number. All right, so that's the only thing you have to really pay attention to, that you don't think of it as normal rounding here. We always go up. And now I can tell you that we need to sample at least. So this is still bare minimum. So more data is generally better. So the more data we have, the better off we are. But at the very, very least, you're going to need at least 55 churros. If you'd like to estimate the true mean calories in Alchester's churros, if you want to be 95% confident and accurate to within 8 calories. So remember, above, the researcher only had 10 churros in their sample, and they had a bigger margin of error, 19 calories. So we have a smaller margin of error, but we do need to collect more data. All right, so that is how we find our sample size when estimating an unknown mean.